All right, just picking up here with video 2. I've got my calculator going again. So just to show you how you could do this on the calculator, you could go to y equals 2, and then you could say this is going to be 2, and then raised to the, now in the power you have the whole x minus 5, so I'll use parentheses and say this was x minus 5. And so now I can hit graph, and I'll get a very similar graph to what I have on my paper on the right. And I could even go to the table. I could hit second graph to the table, and I could see different values. So I could see 5.1 is a point, 6.2 is a point, and see the increase in these y values here. All right. So with that, we'll move on to the next problem here. Number 4 says a population numbers 17,000 organisms initially and decreases by 7.1% each year. Suppose P represents the population and T is the number of years of growth. An exponential model for the population can be written in this form: P equals A times B to the T, where P is equal to what? So to fill this in, we had an example like this in the notes. This A, this is your initial starting amount. So we started with 17,000. And now be careful with your B. It's all about the percentage that's left. So if it's decreasing by 7.1%, we could say 100% minus your 7.1%. That's going to give you 92.9%. So if I'm decreasing by 7.1% each year, I'm left with 92.9% each year. So it would be 0.929 as my B raised to the T. Just like that, number 4 is done. On number 5, I've got to evaluate this log of 0.51 of 0.76 using our calculator. We've got to show the change of base used in this calculations. So I can't do this by hand with these decimals, but I could use the change of base. I could say this is going to be the same thing as the log of 0.76 divided by the log of 0.51, both of those with bases of 10 like your calculator can do. So we'll go log of 0.76. And then we'll divide that by the log of 0.51. And so I get 0.4076 when I round that to 4 decimal places. So 0.4076. Moving down to number 6 here. Bank features a savings account that has an annual percentage rate of R equals to 3.4% with interest compounded quarterly. Chantel deposits $7,000 into the account. The account balance can be modeled with this exponential formula here. Formula notes that I said you get on the test will look very similar to this. S is the future value. P is the present value, the current value. R is the annual percentage rate as a decimal. N is the number of times each year that interest is compounded, and T is the time in years. So fill in the missing values for P, R, and N. P, your initial rate is $7,000 from right here. R, our interest rate is 0.034. And then N, if it's compounded quarterly, there are 4 quarters in a year, so N is 4. So how much money will Chantel have in the account in 10 years? Round your answer to the nearest penny. So I'm just going to plug into this formula right here. Again, that P is 7,000. B1 plus R was 0.034 divided by that N of 4 to the N times T. So 4 times 10 because we're dealing with 10 years. And so I'll just calculate this on my calculator over here. So we'll go 7,000 in parentheses 1 plus 0.034 divided by 4. I'll close the parentheses like the formula does and then raise it to that power. That 4 times 10, well, that's just 40. So I can enter that in, and there's my amount. It'll be $9,820.51 in 10 years. There's my result for that one. Moving to number 7. Write the expression log of x17, y13 over z12 as a sum or difference of logarithms with no exponents. Simplify your answer completely. So the first thing I'm going to do is split this into 3 logs, one for the x, one for the y, and one for the z. So this will be log of x to the 17th plus log of y to the 13th minus a log of z to the 12th. When we're multiplying, we can change that to addition with our logs. When we're dividing within the log, we can change it to subtraction between the logs. And now the final step is I can bring these exponents down out front. And so my final answer will be 17 log of x plus 13 log y minus 12 log of z. And that's as simplified as that can go. Moving to number 8, a multiple choice question here. Choose the graph of log base 2 of x minus 4 outside of those parentheses. Check the corresponding graph. So I can narrow down my choices. First off, it's a log base 2. Since that base is above 1, I should see an increasing graph. So it's not this one or this one. These two are decreasing. But the first one is increasing. It's headed up from left to right. So is the second one. It's headed up. Now I can use the minus 4. A minus 4 outside the parentheses. This is a shift down. And so out of these two, which one has been shifted down? Well, it has been this one. So I would put a check mark next to that graph. Moving on to page 5 of our practice test here. Evaluate each of the following without using a calculator. Must show your work to receive credit. So there's not a lot of work to show here. I mean, you can just zoom through these pretty quickly. On the test, feel free to use your calculator to check these using change of base. But log 6 of 36 is equal to 2. This is the same thing as 6 squared is equal to 36 using that log loop around. This one would be -1 because 5 to the -1 is equal to 1 over 5. This would be 1 because 2 to the 1 is equal to 2. Remember that ln and e are inverses. They essentially cancel each other out. So all that's left here is 5. This is an understood base of e. E to the 5 is equal to e to the 5. This would have to be 0 because 3 to the 0 power is the only way to make that to 1. Once again, e's and ln's are inverses. This is just square root of 7. And this is another 2 because 9 squared is 81. On number 10, simplify this completely into a single logarithm. So the opposite direction of what we just did. The first thing I'll do is bring this 4 up to my power. So it's log 4 to the 4th. And I'll bring this 3 up. So it's plus log x to the 3rd. And then I can combine this into a single log as 4 to the 4th times x to the 3rd, or 4 to the 4th x to the 3rd. And I'll go ahead and use my calculator and I'll find what 4 raised to the 4th power is. It's 256, as we can see there. So this is really log 256 x to the 3rd. And I can put some parentheses to show it's log of all of that. Right. So we'll stop this video here and move into video 3 for problem number 11.